All right, this is a very straightforward problem. What we're going to do is we're going to add the forces. Now, since we're trying to find the force on this minus 85 microcoulomb charge here, we have to do a force from the 75 and a force from the 48 and add the two together. So let's first determine the direction of all the forces, and we'll do that with a red arrow. So the first one from the 75 will go to the left because the negative will be attracted towards it, and the second one, because it's positive, will also be to the left. So we have to add those two forces together. So let's label them and then we can get to work. So the first one, this is F1, and this one is F2. So the total, when we get done, my resultant force Ft is going to equal F1 plus F2. So we have to find F1 and F2. So F1 will follow our force equation, which will be K Q1 Q2 over R squared. So that'll equal K, which is 9 times 10 to the 9th, times the first charge, which will be 75 times 10 to the minus 6, times 85 times 10 to the minus 6. Notice I didn't use the negative sign because I took care of that when I drew my diagram, divided by the distance between the two, which is 0.7. We have to add the two together, meters squared. So F1, when we take our calculator and do that calculation, we get 117 newtons. And we got to do the same thing for F2. So F2 will equal 9 times 10 to the 9th, using the same equation, 48 times 10 to the minus 6, 85 times 10 to the minus 6, and we'll divide that by its total distance, which is 0.35 squared. So F2 comes out to be 300 newtons. Now they're both in the left direction, which we usually call negative, so our final force Ft will equal negative 117 plus negative 300. So our final force Ft will equal minus 417 newtons. And we are finished.